Welcome back, everybody. As promised, here is an episode on the Typhoon's propeller. If you haven't already subscribed to our YouTube channel, please do. As soon as we hit the 10,000 subscriber mark, we're going to release a whole bunch of products, t-shirts, and other kind of things that you guys can get a hold of, phone covers, and all sorts of stuff with our logo, with Typhoons on them. It's going to be amazing, and every penny will go to support the project. We just need the subscribers before we can have that happen. So please subscribe and tell a friend. Without further ado, here is our propeller episode. Hi guys, so I hinted at the end of last episode that the next episode will be on the propeller, and I'm going to stick with it. I wasn't sure then, because I've got a couple little projects going, and I think it's probably a good one to touch on because it's actually a major aspect of the project that we don't speak too much of. And I guess the first thing to note is that the Typhoon's propeller, they had 3 different versions or variants of a de Havilland propeller used on the Typhoon. The original one, the 3-bladed propeller, there's an interim propeller, a 4-bladed propeller, pre-mod or pre-production mod 339, which was a 4-blade propeller, and then there's the production 4-blade de Havilland propeller that was put on Typhoons. We've got a little bit of information out there. Our website isn't really that up to date. I don't have time to update it and keep up on it. I'd rather be doing this stuff. But some of the information that's on there alludes to the fact that JP843 was actually built as a 1B Typhoon with a car door type canopy and a 3-bladed propeller. Now, we've got a picture of JP843 early June of 1944 with invasion stripes painted on it. And this was after it had served with 197 Squadron. It was delivered from the factory to 197 Squadron, the sister squadron to 486 New Zealand Squadron, and saw combat, quite a bit of combat, and flew with a number of well-known pilots with 197. But in early of, I say January, February of 44, the newer sliding hood canopy Typhoons were coming into play, and some of the newer modifications are coming off the production line. So JP843 was sidelined by about February of 44. And she went in for refit for rocket projectile modifications and the sliding hood. So at that point in time, she went from the car door type to the sliding hood canopy, and was eventually delivered to early June of 1944 to 609 Squadron, and painted up with some beautiful D-Day markings. So all in all, she never saw the modification 339, which went to the 4-bladed propeller. And that's important, for me anyway. It's important to keep that because it's really the orientation that the aircraft flew in. And along with the modification to a 4-bladed propeller, or coinciding with it, a lot of the Typhoons are also fitted with a larger tailplane. I think, I'd have to check with Chris Thomas about this, but I think there was only one Typhoon that ever actually flew with a 4-bladed prop in the smaller tailplane. The larger tailplane added a lot of stability, and you'll notice that all of the bombfoons, the guys that were carrying the 1,000-pounders, they all had the large tailplane. So the rocket projectile Typhoons, they got away with keeping the smaller tailplane, and a lot of them kept the 3-bladed prop because of that. So we're going to keep it, keep JP843 exactly as she flew with the 3-bladed prop and the smaller tailplane, but it does make things a little bit difficult in the propeller world. So propeller blades were a big thing for us, and it's taken quite a bit of time, and again, working with the Halifax 57 project, we went in on a blade scan, and the guys down in Indiana there very kindly loaned their Typhoon blade, which was a surviving new old stock blade buried in earth, from the loan of Hawker Typhoon MN235 that they dug up and they have in their museum now. So we were able to borrow that and have it laser scanned to get the dimensional data from that. We've also since found or very graciously been donated a original manufacturer's drawing of the correct contours for this blade profile. So we've completed all the blade design work that we need for these 3-bladed props, and that helps out. Again, it's applicable to a number of projects that could benefit from this data, and that's the Halifax used the same blank, different length blade, but from the same blank, so the same geometry, and I believe the Sterling, the Beaufighter, and of course the Typhoon. So it's slowly coming, and we're hoping that the work that we're doing here will help a lot of people. So now that we've sort of more or less solved the blade issue, I say more or less because I'm leaning towards a composite blade. We've talked to GT Propellers, and they've said that they are able to make a composite blade to fit our hub with the power rating required for the Typhoon, certified. And that appeals to me because if there's ever a prop strike on this aircraft, given the rarity of the Sabre engine, it'll likely preserve the engine and destroy the prop, which is absolutely the best case scenario. Trying to get a hold of original aluminum blades. All 3 of the variants that flew with the Typhoon had aluminum or duraluminum blades, and trying to find those and having them airworthy is going to be very difficult. Trying to have them forged, because they're a forged component, and machined is going to be very expensive. Doable, but very, very expensive. So I'm leaning towards the composite prop blades if we can sort out weight and balance on this aircraft because of the massive size. I didn't mention this is a 14-foot diameter propeller in all cases, 4-blade or 3-blade. It's 14 feet in diameter, so this is a massive chunk of metal. So still kind of working on that, but really resolving most of the big issues on data and geometry for the propeller blades. We've now really been focusing on the hub, and it's one of those projects within the project that I kind of bounce back and forth with, and I believe Carl does too over at Halifax. He's probably more into it than I am, and every once in a while he gives me a poke and gets me going, and that's kind of what's happened here. We've had this hub sitting around for a while. This is a crash recovered Hawker Typhoon de Havilland 3-blade 5500 series propeller hub, and we've actually got the blades, at least 2, maybe all 3 of the blades with it as well. They're very poor condition. It came out of muddy salt water from my understanding, so we've been playing with it for a while. I gave it to Graham Allen to play with for a little bit. We just wanted to open it up. This is the prop nut that holds the dome in place here, and it's a little finicky, as you can imagine, being muddy, silty salt. We've got some issues with there, and a very high torque piece. So this episode, I'm going to go through this, give you that information on what we're doing, what we need, and what we're looking for, and just kind of show you where I'm at with it. I've got the Spider, which is basically the hub that fits onto the engine and has spokes that come out for each blade. I've got that sitting on the cockpit fixture table just in the distance there, but I'm just going to show you the hub because it kind of ties into something from the previous episode that I thought was interesting. A lot of people commented when I was pulling the spars apart about the application of heat and the application of different kinds of penetrating oil that they've used, and that's awesome. It's always good to get other people's experience because it can put us a leg ahead. Mouse milk was mentioned as a penetrating oil, as well as Aerocroil or Croil, which are both excellent. And I actually, the Aerocroil is something that I found when I was an apprentice in a machine shop, and it was fantastic, absolutely fantastic stuff. I never had any issues with it. Lately we've been using a 3M product, and I don't have the can here. I just ran out. It's something that Rob Roy introduced us to, and it works brilliantly, and it doesn't have an odor to it, so using it in the shop you don't get high. But I just ran out of my last can, and because of the whole COVID shenanigans here, we've got Rob hasn't been in, and I had to come up with another solution. So this is a solution here that actually came from some of the research that we did on soaking our Sabre engine. That's also sitting back there. You guys have seen it in the background. And we've got a steel tank that was built that's big enough to soak a Napier Sabre engine and a couple landing gear legs as well. We've got 3 landing gear legs in our storage building. And the idea was just to dump them in there and let them sit for a year. And then we started getting into the science of it and thinking about heating and cooling and even using ultrasonic vibration to help loosen and just get things moving. Well, I think we can safely say that's not going to happen for a little bit, although it would be really nice to put the effort into getting it soaking. We did come out of it with a couple different soaking mediums, and one idea was to talk to the guys at Croyle and about Air Croyle and say, hey guys, we have this Napier Sabre engine that was submerged in salt water that we want to pull apart, and it'd be excellent marketing if you guys wanted to sponsor us, and we'll fill the tank with Croyle, put the Sabre in it, take it out and disassemble it, and there you go, perfect marketing campaign. But we also looked into some homebrew options for penetrating oil, and it came at a good time here because I just squirted the last little bit of the 3M product from Rob on those cross tubes for the cockpit structure. And this is one version of what we were going to use for that, and we actually decided not to use this one in the tank because it's probably a little bit more volatile than you'd want sitting outside, even in hot sun. But it's a 50-50 mixture of, well, most people use ATF, automatic transmission fluid. They have a lot of cleaning compounds in them, and acetone. So 50-50 ATF and acetone. What I've got in this bottle here is a 50-50 mix of ATF, sorry, a 50-50 mix of acetone and 5606 hydraulic fluid. So it's just what we had available, and I'm expecting very, very similar results from it. But this nut has been a problem for Graham, it's been a problem for myself, and you've probably noticed this hub sitting on the bench, and it's going to sit there until it comes off. So I figured I'd give it a little bit of a clean here. I've got my scriber. I can't use the slang term for it on YouTube, but I've got my scriber here, and I'm just going to pick down into the seams on both sides because the nut's nested between the barrel half and the dome. So I'm going to pick in between there. Should probably put these on, and I can see already that there's still sand and garbage coming out of there, and I've been doing a lot of investigation into part numbers as well on the dome, and I didn't want to sandblast it right away because some of them are so light that the sandblasting will actually obliterate them. So I hit them with some Scotch-Brite, non-abrasive, non-woven abrasive. I just use little chunks of it when I'm doing it, and slowly just polished little areas until I got to all of the part numbers, and we were able to absolutely confirm that it is what it should be. De Havilland 5500 series prop. We've even found the serial number on it, which is quite nice. Not that we have coinciding logs or usable components out of this one. So that's that. I'll just grab, this is thanks to Cam. Did a great job getting this set up. Automatic sucking device, so here we go. Very nice, and it saves blowing a lot of dust and junk around the shop here that eventually needs to get picked up anyway. So just see if I can give it another little scrape here. So another little tidbit that I learned about the mixture of a hydraulic fluid, or in this case 5606, and acetone, is that they actually kind of separate from each other just like oil and water do. So it seems to have settled itself in together nicely, but it takes a bit of shaking to get it to really work together. So now I'm going to soak this. We've got a nice little trough, at least for the inside, and there's a bit of a groove here that hopefully will keep some for the outside thread, and we'll see if we can get it to disappear. Do a little bit of cleanup. Just be careful if you're doing this, if you're trying any of these. I don't, I'm not liable for what you do with it. These are experiments at our end and should only be done by, I don't know. Just be careful. So there we go. We'll let that soak for a little bit. I'm going to push it off to the side, and I'll take you guys over to the other table and show you what's going on with the spider. So this is the spider, and as you can see, it's still got the root end of one blade, and at some point the blade was cut off. As I mentioned, the blades are in storage. They're in very poor condition. You can see I've already pulled one root end. This one broke off in the crash, and you can just see the amount of exfoliation corrosion around here. Again, saltwater environment, and I believe it's a 4000 or similar to a 4000 series aluminum used in the forgings for these. So I forgot I put those in there. So pretty rough shape. Kind of nice though that there's still a couple markings on it. You can see all the prop blade part numbers right there. There's a drawing number DP4551157/1, which is the Typhoon blade number. Good to know. And so I've pulled one of these off. One was already off. You can see there's quite a bit of corrosion in there still. Nothing's really been cleaned up. Where there was tight veined surfaces, you can see it kept a lot of the moisture and salt out of there, so it preserved it acceptably, I guess. This is not a spider that will be used in an airworthy aircraft by any means, but we'll see what we can do with it, and it may have potential to become a ground running spider. We'll see. You can see here there's some other parts that came out. This is a bushing at the root end of the propeller blade. It goes inside the propeller blade, and it was stubborn, so had a bit of a fight with that one. What I need to do with this one now is pull this other blade root end. I've prepared my implements of destruction, and I'm going to start by pectoraling this one. This was the easy one, as you can see, because it broke off and it left so little material there. It took a while to pectoral that, I tell you. This one, I've basically got the entire spoke length. You can see the washer right there for where the end of the bushing is and the propeller plug is. I'll try and get some penetrant on that now and get it soaking while I pectoral, just to use that time as best possible. You can see, I don't know if the camera will pick it up, but I've left this alone for a little bit, and you can see it's starting to separate again. So it sounds like it's probably one of the best penetrants out there, equal or better than all of the commercially available ones. But I think a trick to it is making sure that it stays together. So I'll put a little bit on here, just get the root a little bit damp, and I'll just watch it as I go and reapply it as needed. But I want to keep it wet. There's going to be corrosion and things that absorb this. It'll be wicking into some of the areas, which is what we want it to do. So I should also clarify that this is not how most of the aircraft work goes. It's not normally this heavy-handed. Whoa! There we go. That was a good test. I got a spark off of that, and I'm still here. So you might also notice through this that I use my gloves until there's no use left in them anymore. Gives me extra dexterity. I mean, that's why I leave that. But still good gloves. So let's get to pectoraling. So for those of you who are not familiar, pectoraling is just a method of cutting using a series of holes. So I'm going to have to go, I think I've got a number 30 drill bit, which is 1285, or just above 1/8 of an inch. It's a standard drill bit for drilling 1/8 rivets, drilling holes for 1/8 rivets. And I'm going to drill all the way along this piece, and then I'm going to increase the size, and I think I've been going up to a 3/16 drill bit, and then a 6-inch one for the longer areas. And basically once I've drilled the small holes, I'll drill 3/16 holes in their place, and then I'll be able to use the longer one, and it's not good for the drill bit, but then I drill and pull sideways, and it basically cuts open the little bit of web that's left in between each one of the holes. And that'll give me a relief in this blade, and we can either wedge it open and slide it off, or figure something else out when the time comes. My only concern, and I don't think it's really a big one, is that these bushings go into the blade root like this, and those screws are screwed into the root of the blade itself. So I want to be able to remove the blade root and leave the bushing on, or ideally get that bushing right off of there by itself. So we'll see what happens, but the intent of the PEC drill in this case is to remove this large piece, and we'll deal with this after. If it comes off at the same time, even better. So I'm just going to draw a rough, or scribe a rough line on it. It is a shame to do this, but really, I mean, there's not too much use for these things. In time they're going to continue to degrade like this one has, and I don't know about stopping it. I suppose we could stick it in a lathe and spin it down and preserve it somehow, but if anybody out there wants one of these and wants me to clean it up for you and are willing to make a donation, I'd be happy to do so. So you just let me know. So here we go. Whoop. Lube. So I can see just a little bit of swarf coming up from the drill bit in these holes that I'm coming into contact with the bushing now that we've gone through that big chunk of corrosion that's in there. All right, so that concludes our 1/8 holes, and let's move on to some 3/16.